Good afternoon, all of you. In today's lecture of Mathematics Practical, we solve first practical of calculus 1, practical number 1, real number. प्रिवियस लेक्चरमध्ये तुम्हाला क्वेश्चन्स दिलेले आहेत प्रॅक्टिकल 1चे. होपफुली तुम्ही ते सॉल्व केले असतील. तरी आपण आता डिटेलमध्ये सॉल्व करूया प्रत्येक क्वेश्चन. जे काही सिमिलर क्वेश्चन्स असतील ते तुम्ही सिमिलरली सॉल्व करायचे आहेत आणि एक नोटबुक करायची प्रॅक्टिकलसाठी. त्या नोटबुकमध्ये सेक्शन 1, सेक्शन 2 राईट डाऊन करायचा. त्याच्यामध्ये प्रत्येक प्रॅक्टिकल लिहून काढायचं आहे. ज्यावेळेस तुम्हाला जर्नल अवेलेबल होईल त्यावेळेस हे जे क्वेश्चन्स आन्सर आहेत ते तुम्ही जर्नलमध्ये लिहायचे. नाव वी डिस्कस दी फर्स्ट क्वेश्चन ऑफ प्रॅक्टिकल नंबर 1 of calculus 1. Heading of practical is real number. Now we start with the first question. Show that if x and y are rational number, then its addition and multiplication is also rational number. आता आपण रिवाइज करूया. रॅशनल नंबर म्हणजे काय? x हा रॅशनल नंबर असेल then x can be written as some p1 upon q1 where q1 is non-zero and GCD of p1 q1 equals to 1. Here x and y are both rational number, therefore it can be written as p1 upon q1, p2 upon q2. Now the addition of x plus y is p1 upon q1 plus p2 upon q2. Denominator same केला आपण q1 q2. इकडे p1 q2 plus q1 p2. But here we observe that all that number p1 p2 q1 q2 are the integers. Hence its denominator is also integer, numerator is also integer and denominator is non-zero. And also here GCD of p1 q1 is 1, GCD of p2 q2 is 1. Hence the GCD of p1 q2 plus q1 p2 and q1 q2 is also 1. Therefore x plus y is a rational number. Similarly x into y, it can be written as p1 p2 upon q1 q2. It satisfies the condition of rational number. Therefore x into y is also rational number. Question number 2, if x is rational, y is irrational, then x plus y is irrational number. Also if x is non-zero, then we have to show that x into y is irrational number. The proof is same on the previous one. Next question, prove that root 3 is irrational number. आपल्याला प्रूव्ह करायचं रूट 3 इरॅशनल नंबर आहे. तर आपण कॉन्ट्रडिक्शनने प्रूव्ह करणार आहे. जर रूट 3 रॅशनल नंबर असेल तर रूट 3 तुम्हाला p अपॉन q असा लिहिता येईल. मग आपण p अपॉन q लिहिला, दोन्ही साईडचा स्क्वेअर केला तर 3 इज इक्वल्स टू p स्क्वेअर अपॉन q स्क्वेअर. मग p स्क्वेअर कसा मिळाला इज इक्वल्स टू 3q स्क्वेअर. बट 3 डिवाइड्स 3q, देअरफॉर 3 डिवाइड 3q स्क्वेअर. इथे स्क्वेअर पाहिजे. 3q स्क्वेअर विच इज इक्वल्स टू p स्क्वेअर. 3 डिवाइड्स p स्क्वेअर, that is 3 divides p, कारण 3 prime आहे. therefore p equals to 3 into some k1. Now the equation put in equation 1. Now equation 1 becomes p ची value 3k1, that is p square 3k1 square. Hence it is 9k1 square is equals to 3q square. Therefore we obtain 3 into 3k1 square is equals to 3q स्क्वेअर. मग आता काय झालं, इकडे 9 होतं म्हणजे आपल्याला काय मिळालं, हा q स्क्वेअर कसा लिहिता येतो, 3च्या मल्टिपलमध्ये लिहिता येतो. देअरफॉर 3 डिवाइड्स 3k1 स्क्वेअर विच इज q स्क्वेअर, दॅट इज 3 डिवाइड्स q. देअरफॉर q इक्वल्स टू सम मल्टिपल ऑफ 3. नाउ p इक्वल्स टू 3k1, q इक्वल्स टू 3k2. देअरफॉर 3 इज कॉमन डिवायझर ऑफ p and q, which is contradiction since common divisor, greatest common divisor of p and q is 1. Therefore our assumption is wrong and root 3 is irrational number. On the same way we prove that root 3 plus root 7 is irrational number. Next question, question 2, find all real number x which satisfying the following inequalities. What is question? The x satisfy x square is strictly greater than 3x plus 4. Now solving this question, suppose the set contain all x such that x square greater than 3x plus 4. हा 3x plus 4 greater than or equal to साईनच्या पलीकडे गेला तर मायनस झाला. फॅक्टर पाडले, x minus 4 into x plus 1 strictly greater than 0. दोन फॅक्टर आहेत आणि दोन फॅक्टरचं मल्टिप्लिकेशन पॉझिटिव्ह आहे, असं कधी असेल, एक तर ते दोन्ही पॉझिटिव्ह असतील किंवा दोन्ही निगेटिव्ह असतील, तर मग त्या दोन्ही केसेस आपण काय करूया, कन्सिडर करूया. जर दोन्ही पॉझिटिव्ह असेल तर काय होईल, x-4 स्ट्रिक्टली ग्रेटर दॅन 0 मीन्स x इज स्ट्रिक्टली ग्रेटर दॅन 4 अँड x+1 स्ट्रिक्टली ग्रेटर दॅन 0 मीन्स x इज स्ट्रिक्टली ग्रेटर दॅन -1 or means we can union of that set, or if x-4 less than 0 then x less than 4 and x+1 less than 0, that is x is less than -1, therefore it is an solution. Now for the next set, 1 is less than x square less than 4. Now consider the set A containing this x belongs to A if and only if x square greater than A and x square less than 4, but x square greater than A if x is greater than 1 or x is greater than -1. दोन्ही साईडचं स्क्वेअर रूट घेतलं तर 1चं स्क्वेअर रूट +-1 होईल, किंवा एक्स स्क्वेअरचं स्क्वेअर रूट काय म्हणणार तुम्ही, +-x. म्हणजे काय आलं आपल्याला, इफ x इज ग्रेटर दॅन 1 और x इज हिअर इज रॉंग or x is less than -1, that is if the criteria x square greater than 1 means if x is greater than 1 or x is less than -1, or if x is less than 2 or x is greater than -2. Now combining all of the cases we have either x belongs to that set, म्हणजे ह्याच्यामध्ये कोणत्या केसेस येणार आहेत, x greater than 1 or x greater than -1 and x greater than 1, that is x belongs to 1 to infinity, x less than -1, here is wrong, we solve here, x greater than 1, that is x belongs to 1 to infinity or therefore union, and x less than -1, that is x belongs to -infinity to -1, or in the second case x less than 2 or x greater than -2, that is x belongs to the open interval -2 to 2. Now the union of this all becomes the open interval -2 to -1 union 1 2. Now the next example we solve as usual or as previous one by considering the cases. Now next question, find all x belongs to R that satisfy the following equality, that satisfying the following equality. Let us question is that mod of x plus 1 plus mod of x minus 2 is equals to 7. In that we consider the all cases if term is positive or negative. If the first case, that is mod of x plus 1 plus mod of x minus 2, such that quantity, case number 1, if x plus 1 is positive and x minus 2 are both positive, then mod of x plus 1 is x plus 1, mod of x minus 2 is x minus 2. Then we obtain the calculation x equals to 4. If both are negative, then its mod is negative, that is we obtained x equals to -3. If suppose one of the positive, that is x plus 1 is positive, x minus 2 is negative, then if we substitute the mod of x plus 1 is x plus 1, mod of x minus 2 is minus of x minus 2, then we obtain the equality as 3 equals to 7, which is not possible. And the last case, suppose x plus 1 is negative, x minus 2 is positive, then we get contradiction. Therefore solution is obtained in only 1 and 2 case. Therefore the solution is a set which satisfying mod of x plus 1 plus mod of x minus 2 is equals to 7 is either x equals to 4 or x equals to -3. Now the second example, that is mod of x plus mod of x plus 1 is strictly less than 2. It is solved by the similar cases if mod x is greater than 0 and mod x plus 1 is greater than 0. Both are negative, one is negative, other is positive, and so on. The next example is also solved by that way. Now the next question, find the supremum and infimum of the set. सुप्रीमम आपण कसा फाइंड आउट करायचा, सगळे मॅक्सिमम काढायचे आणि मॅक्सिमम अप्पर बाउंड काढायचे आणि सगळ्या अप्पर बाउंडमधला लिस्ट वन विच इज सुप्रीमम, अँड फॉर इन्फिमम फाइंड आउट ऑल लोअर बाउंड अँड द ग्रेटेस्ट वन इज नथिंग बट इन्फिमम. Now for that purpose we define a set, substitute the values of n, that is n runs from 1 2 3 4 and so on. Substitute the value of n equals to 1, 1 plus 1 by 1 that is 2, 1 plus 1 half, 1 plus 1 by 3, 1 plus 1 by 4, up to 1 plus 1 upon goes to infinity, that is goes to 0. Therefore the value goes to 0, that is 1 upon n goes to 0, 1 plus 0 goes to 1. Hence in that set the infimum is 1 and supremum is 2. Similarly, find out the largest and smallest value for the next set. Here the set 1 upon n goes to infinity, 1 upon n goes to 0, infimum is 0 and supremum is 1. Hence we solve the remaining problem as usual way. Therefore that is practical number 1. Solve that practical and write down each practical in a separate notebook for a mathematics practical. If journals are available, then we can write all that practical in the journals.